All right, here is a video for lesson 425 focusing on how to solve for expected value and fairness in a game of chance. And what does it mean to be fair in a game of chance? Okay, we're going to start here and we're going to talk about if we played this game 10 times. And the game is you can spin the spinner and whatever it lands on is the amount of money you get. So if it spins and lands on 0, you get $0. If it spins and lands on 4, you get $4. And we're talking about, okay, how much money can we expect to win if we play this game 10 times? And logically thinking, many of us can come up with that the answer is $20. Now here is one way that we can calculate that to be sure. All right, because half the spinner is worth 4 and half the spinner is worth 0, half the time we play the game, we're going to win money or we're going to get 0. And so the way I write that out is 1/2 of the time I play the game, 1/2 of the time that I play the game, which is 10 times, I'm going to win $4. In addition to that, the other half of the time I play the game, and the 1/2 and the 1/2 are telling me, okay, that's all the different options I can have, either 1/2 going to the $4, 1/2 going to the $0 here. But again, 1/2 of the 4 times I play, I'm going to end up with $0. When I calculate this out, I end up getting 1/2 times 10, which is 5. 5 times 4 is 20. And then addition, 1/2 times 4 is 2, 2 times 0 is 0, so that's just 0. And I add it, and I get that $20 would have been the correct answer. Let's see one more for 30 times. And again, same kind of thing. If you play the game 30 times, half the time, and this is, expected value, and if you play the game, it might not exactly be half and half, but this is, using probability and expected value. Half the time we play the game, we can expect to land on 4. So half the time we play the game, which is 30 times, we expect to land on 4. In addition to that, half the time we play the game, which again is 30 times, we can expect to land on 0. Calculating it out this time, 1/2 times 30 is 15. 15 times 4 is 60. So the other one, 1/2 times 30 is 15. 15 times 0 is 0. And 60 plus 0 is telling me that this would be $60 if you played the game. Now, in this part here, it's just coming up with, what if we played the game n times? Instead of 10 times, instead of 30 times, instead of the 100 times that I'm skipping, what if we played it n times? And so I'm going to rewrite my equations here. Instead of using 10, this is supposed to be 10 here. Instead of 10 and 30, let's just use n, the variable for any number of games. So I have 1/2 times the number of times I play, because I win half the times of the games I play, n, and I'm going to be winning $4, plus 1/2 the time I play, my n times I play, I'm going to be winning $0. Calculating this out, well, 1/2 times n is 1/2 n, 1/2 n times 0, that's 0. 1/2 n times 4, well, that's going to be 2n. So 2n is an equation that can represent what was happening here. And to check, the number of times I played is 10, so 2 times 10, that would give me 20. The number of times I played was 30. 2 times 30 would give me 60, so it's working out. Okay. Now, if we talk about the probability of winning after, or what is the expected value after one spin, so we can use my equation here, which is then 2 times 1, because we're only playing the game once, and I would win $2 if I played the game once. My expected value for playing the game once is $2. Now, what this question was saying here was explain, is that actually at a possible amount to win? And the reason I talk about it in this video and the reason that it's in the lesson is to show you, well, $2 is not part of my spinner. If I spin this spinner one time, I cannot get $2. So why is it $2? Well, it's $2 because expected value is an average over time. It's our expected amount of winnings over a series of games. Now, we can do one game, but like it shows here, it's going to be the average of 0 and 4. And so we don't actually get a number on our spinner, and that's okay, because like I said, it is an average over time. So let's get into some tougher expected value ones like this one and the one after, and then we can kind of wrap up some of the main ideas about expected value and then get into fairness. So this one here, it's a little bit different, but very similar to what I was doing here. Only it's not half and half. I have 1/4 of my circle, 1/4 of my circle, and 1/2 of my circle. So what I can say is, if I'm playing the game 4 times, well, this quadrant of my circle is 1/4. So I know that 1/4 of the time I play the game, 1/4 of the time I play the game, which I'm playing the game 4 times, I'm going to win $4. In addition to that, 1/4 of the time I play the game, which again is 4 times, I'm going to win $100. And then 1/2 of the time I play the game, which is, again, 4 times, I'm going to be winning $0. And I can calculate this to figure out my expected value after playing 4 times. Well, 1/4 times 4 is 1. 1 times 4 is 4. So we get 4 here. Oops, I want to use my math notes box. 4 here, again, 1/4 times 4 is 1. 1 times 4 is 4. In part 2, in the second edition, we have 1/4 times 4, that's 1. 1 times 100 is 100. And then lastly, 1/2 times 4 is 2. 2 times 0 is 0. And so I'm winning, in that 4 times I play the game, I'm winning $104. And I'm going to skip the 100 because it's the same thing. I'm just replacing all the 4s with 100s because I'm now playing the game 100 times. Now this part is the really important part to us, how we can find expected value for just one spin, and then how we can use that to find the expected value for any number of spins. And so I'm going to actually use a very similar equation here, but I'm going to replace all my 4s with 1 because I'm only playing the game 1 time. And so I have 1/4 times 1 because I'm playing it 1 time, and then I'd win $4. In addition to that, I have 1/4, 1 and 100. And then lastly, I have 1/2 times 1 because we're just playing the game 1 time, and 0. Now, I can look at this and I can kind of reduce things down because the 1s are kind of unnecessary because anything multiplied by 1 is itself again. So if I kind of reduce this down, 1/4 times 1 is 1/4, and so I really have 1/4 times 4 plus 1/4 times 100 plus 1/2 times 0. That's just reducing down, kind of getting rid of the 1s because I don't really need them. Okay? And now this is the way that we can set up, right here, this is the way we can set up solving for any expected value of just one spin. And the way I say it when I look at this is I say, okay, what we can do then is we can take the fraction of the circle and multiply it by the value of that fraction of the circle. And then we create a chain of addition doing the same thing. So 1/4 of the circle has a value of 4, so that's my first one. In addition to that, 1/4 of my circle has a value of 100, so I'm making that multiplication. And then I'm going to do an addition with the rest of my circle. 1/2 of the circle has a value of 0. And so you make this chain of addition until you have every sector of your circle in your chain of addition and multiplication. Now to finish this off, 1/4, let's do the multiplication and addition. 1/4 times 4 is 1. 1 plus 1/4 times 100, which is 25. So 1 plus 25 plus 0, so that's going to be $26 here. Now that's my expected value per one spin. Let's make sure that it would work for 4 spins. So 26 times 4, 26 times 4, and it does, and I'm using it on my calculator. I was going to type it in here, but 26 times 4 is going to give me that 104 value, and you can check it on your calculator as well. Okay, let's get into another one that's a little more complicated. Oops, I didn't mean to cancel out of there. Number 4 here, a little tougher, and we're just going to do the expected value. And I'm going to use that method to find that for that one spin. So I'm going to look at, okay, what fraction of the circle and what's the value? Well, the first one, that's 1/4 of the circle, and that has a value of 6. So that's my first multiplication here. In addition to that, because I'm making this chain of addition until the circle is complete, 1/4 of my circle has a value of 2. In addition to that, this is where it gets a little trickier because it's not so obvious that it's 1/4, 1/4. We have to try to think, how can we say what fraction of the circle this is? Well, the way I like to do it is I say that I know 45 degrees here. I know that this is a 45 degree segment of my circle. And I also know that there's 360 total degrees in my circle. So this is just 45 out of my total 360 degrees. So I can set a fraction up that way and say 45 over 360 is my fraction of this portion of this. And that portion that's 45 out of 360 has a value of -2. Now, same thing kind of for number 5. If this is 45, I know that this segment here needs to be 135 because 45 and 135, they create 180, which is half a circle, which we need right there. And so I have then 135 over 360. That fraction of the circle has a value of -5. Now I can reduce these fractions down. The first ones I can't. I mean, that's 1/4 times 6 again. Plus 1/4 times 2 plus, when I reduce this fraction down, it actually becomes 1/8 times -2 plus 135 over 360 reduces down to 3/8. Oops. 3/8. And that's times -5. And then you can use your calculator to solve that one. And what you should get is, I believe, a -0 equals negative, I want to keep this in the box, -0.125, I believe is the correct answer there. So that's going to help me get into this discussion of fairness here at the end of the video. Now it's asking us, with that, now that we know the expected value, do we think that this spinner is fair? Well, according to the spinner, I'm losing this amount of money every time I play the game, or I'm expecting to lose money every time I play the game. And I don't know about you, but I'm not about to play a game where you lose money every single time. And so for a game to be fair, I don't want to lose money. And for a game to be fair for the person creating it, they don't want to lose money. Meaning if you're winning money every time, they're paying you. And if they're losing every time, you are paying them. And so you don't want either to be overweighted. You don't want either to be one or the other. You want it to be perfectly balanced where it's 50-50, you win sometimes, or the person setting up the game wins sometimes. And so for a game to be perfectly fair, we need an expected value of 0. Spelled expected wrong. That's accepted. Of 0. All right. And we're going to do, I'm just going to kind of highlight some of the other big ones here. This I need to correct, needed to say 1/8 of the circle. And then what you need to do here is you can say 100, there's a 1 in 8 chance that you spin 100. There's a 1 in 4 chance you spin a 10, a 1 in 4 chance you spin a 5, and a 3 in 8 chance that you spin a 1. And the same goes for the left side. What you need to do in this problem is fill out this diagonal of boxes to figure out, okay, what is the actual probability of spinning 100 and 100, a 10 and a 10, a 5 and a 5, and a 1 and a 1, and then you're going to use those probabilities to set up your expected value. So for example, the 100 and 100, that would be a 1 in 64 chance because that's 1/8 times 1/8. So when I start setting up my expected value in this case, it is 1 out of 64 times that value of 100, and I can start making my chain of addition with the other boxes as well. And the only reason this one's different is because it's a double spin. You need to spin the 100 and then you need to spin it again to get the money. And the other ones, you just needed to spin it one time. And since you need to spin it twice, it creates another event and you need to figure out the probability of it actually happening. Last one here, expected value. Where you know the expected value, you need to find x. And it's similar, it's just working in reverse. You have 1/4 times the value of x plus 3/4 times the value of 2, and that needs to equal 3 because it says in the problem the expected value is 3, and then you need to work this out algebraically and solve for x. Sorry for the long video. There's a lot to explain in this lesson, and I wanted to give you the most I could showing you what these expected value problems look like. Any further questions, please always reach out, let me know.